Okay, this video is going to show you how to use the combined gas law, which is pressure times volume divided by temperature. Now for this particular problem, I have included the units of millimeters of mercury, which is Hg. Volume, we're going to use liters, and we're going to start with degrees Celsius. The only trick in doing a combined gas law problem that involves temperature in Celsius is that you have to first convert into Kelvin. Okay, so just a couple of warning signs for doing a problem that involves temperature. Okay, whenever you take that amount of degrees Celsius, you add 273, and then that gives you the units of temperature in Kelvin. Okay, now depending on your teacher, they may use 273.15, depending on if the teacher is super precise with things. But I'm just showing you how to use the formula, so you have to adjust if your teacher uses a more precise value than 273. Okay? All right, fair enough. Let's read the problem together. It says a sealed container is at 1,520 millimeters of Hg. Okay? And then it contains 7 liters of neon. That's at 25 degrees Celsius. If the pressure of the gas is reduced to 125 millimeters of mercury and the temperature is increased to 40 degrees Celsius, what is the new volume? Wow, that sounded like that was almost impossible to read, and you're probably wondering right now, how am I going to be expected to solve such a crazy problem? All right, well, first you have to know what the combined gas law is, so let's start with that. Now, I said that it's pressure times volume over temperature, and I'm writing little ones here to indicate that those are the initial conditions. Those are the starting conditions, and then what you do is you set that equal to the changed situation over here. Okay, these are like the final conditions. So you may want to go through the problem and figure out what is P1 and V1 and label each of those parts. So every time that I saw a number, you'll notice that I underlined it. It's just good word problem solving technique. Millimeters of mercury is a pressure. That's P1. 7 liters is a volume. That's V1. And the 25 degrees Celsius, that's T1. Remember, we're going to convert that into Kelvin. Now, if we keep digging through this problem, we see that we have another pressure here. So that's P2. And the temperature is reduced to 40. That's T2. And they're asking for the new volume. So it turns out that this new volume is what we're going to need to solve. Okay, so we're going to be looking for V2. But first, let's do some Kelvin converting. So we have 25 degrees Celsius. I'm going to change my pen color here. Let's take the blue pen this time. So we're going to start with 25. We're going to add 273 to find our Kelvin temperature. And you can use a calculator if you want, but this shows up so often. I've got this one pretty much memorized. And that may sound really nerdy, and it is, but trust me, you'll be a nerd too as you memorize more and more of this. Now, if you really want to calculate the temperature using your calculator, by all means, maybe you're nervous, okay, you're taking a chem test or a chem quiz, maybe you want to, write those things down. That's perfectly okay. Use the calculator if you must. Okay, so these are the two temperatures, okay, that were given in the problem. This represents T1, and this represents T2, all right, just to keep things straight. So now we have all the information we need, and we have consistent units. We have the same units for pressure, same units for volume, and now we have Kelvin temperature for both as well. So it's time to do some substitution. All right, so take a little pen here. And let's put some numbers in, shall we? So we have 1520. That's our P1. For V1, we've got 7. For T1, it's 298. And then on this side, we have the final condition. So P2, that's this 125. Glad I labeled it because it makes it easy to find. Now we're looking for V2. Literally, we're looking for V2 because that's the new volume. And then T2, which was what we solved over here, 313 Kelvin. Okay, so we have to do a little bit of algebra. Remember that we have to get V2 by itself. So in order to do that, I'm going to multiply both sides by 313. So I have 313 over here. All right, remember we multiplied just to be really dramatic with the algebra. I'll just put this over here, okay? So you see we've multiplied both sides by this 313. These, of course, are going to cancel, right? And so now I'm going to divide both sides by 125. Again, I'll be dramatic with the algebra to show you every step. All right, so we have 313. Haven't done anything with actually multiplying these out yet. Just kind of reorganizing everything. So divide by 125, divide by 125, cancel, cancel. So V2 is going to be equal to whatever this big monstrosity turns out to be. Now, if you think I'm going to figure that out in my head, you're crazy. Okay, I'm obviously going to use the calculator just like anybody else would. If you can figure this out in your head, you should probably join Mensa or something. All right, bunch of geniuses that they are. So take 313 times 1520 times 7, divide by 125, and you get a very, very large number. All right, now, turns out that there's an interesting phenomena that happens for a lot of chemistry students, and I don't know why, but just round to 1 decimal place there. This is a volume in liters. Now, it turns out that that interesting phenomena that I was about to mention is that chem students get freaked out when they see a very big number, okay? Now, you shouldn't freak out because big numbers happen in chemistry, especially when you're dealing with an industrial process, and it can also become very big when you're dealing with molecules, like if you're counting the number of molecules. So don't freak out if it turns out that your answer came to be a large number like this. I mean, if you really want to, you can check the math and make sure that everything worked out okay. But in this case, I'm pretty confident that the math worked out okay, so I'm not going to double check it. But feel free to download the worksheet, see if you can do this problem on your own, and if you need a little hint, you can always press play, and I'll give you a little hint, and then you can see if you can carry the problem the rest of the way through. That's it. I'm signing off for the combined gas law. Good luck, and watch another video if you need more help.